Welcome back, everyone. We are now going to move on to another fundamental topic of taking a closer look of IP addressing on Azure. Now, you may think that IP addresses are a fairly straightforward topic. However, there are a number of different IP configurations that you need to be familiar with, which will also be an ongoing topic throughout the rest of this course. In this lesson, we're going to start off with a high-level overview of IP addressing fundamentals on Azure. We will then move on to the specific planning requirements when planning out your network, which include the relationship between address spaces and subnets. And then we're going to take a bit of a deeper dive into the number of different IP types on Azure, which include static versus dynamic, various SKUs, and private versus public addresses. From which we will further expand on some exam-specific topics you need to be familiar with, which we will highlight now and will also be an ongoing topic throughout the rest of this course. So jumping on into it, let's start off once again with the high-level conceptual overview of how IP addressing works on Azure. So again, going back to the basics, every virtual machine on Azure requires an IP address. After all, without an IP address, you really can't do very much with a virtual machine. Not much of a surprise there. However, one important nuance is that an IP address is not actually assigned directly to a virtual machine itself. However, you need to know that an IP address is instead associated with a network interface card or a NIC, which is a separate Azure resource. However, that network interface is attached directly to your virtual machine. In fact, every time you create a virtual machine in Azure, you will also see a separate network interface resource which is attached to that individual VM. That network interface is where that IP address lives. Now, this gives us some flexibility in which we have the option of assigning multiple private and public IPs to a single network interface. And for even more complex configurations, individual virtual machines can have multiple network interfaces attached to that same VM as long as they're in the same virtual network. This leads to a scenario in which one network interface can have multiple IP addresses, and a virtual machine can have multiple network interfaces attached to it as well. Sticking with our theme of the fundamentals, you also need to know that all virtual machines must have a private IP address associated with it, well, at least associated with the network interface if we want to be exact. By comparison, a public or an external IP address is technically optional, although you'll notice that when you create a virtual machine with its defaults, it will add it on by default as well. That said, keep in mind that private IP addresses are the only required type of address, and a public IP address is technically optional. Finally, the last fundamental to be aware of is that network interfaces support both IP version 4 and IP version 6 addressing. With that in mind, though, be aware that IP version 6 is not really going to be a strong exam focus. The vast majority of our discussions are going to be centered on IP version 4. However, there are a couple specific IP version 6 topics you do need to be familiar with for the exam, and we will cover those as we get to it. Overall, though, the vast majority of the managed network services we will be talking about in this course are IP version 4 only. However, IP version 6 is possible within a virtual network and attached to virtual machines as well. Moving on, let's talk about some of the fundamentals we need to be aware of setting up IP version 4 addressing within our virtual network. As we talked about in the previous lesson, the primary structure for virtual networks is one or more address ranges, and those ranges can have one or more subnets associated with it. Now, the relationship here is very important, and yes, it may be an exam topic, in that subnets for a virtual network must fit inside of your address range. For example, on the right side, if we have an address range of 10.1.0.0/16, our subnet must fit inside of that range, in which case we have a subnet range of 10.1.1.0/24. 10.1.1.0/24 fits inside of our address range of 10.1.0.0/16. By comparison, if we had a subnet range of 10.0.1.0/24, that would not be a valid subnet inside of our address range because it does not fit inside of our address range of 10.1.0.0/16. Overall, subnet ranges must fit inside of your address range to be a valid subnet. Also be aware that this is the case for both IP version 4 and version 6 addresses. In our example to the right, we have a sample IP version 6 address range ending in a /48 Saturn notation. A valid IP version 6 subnet would have to fit inside of that /48 range, in which case we have a /64 range, which fits inside of the 48 one. Now, we're not going to focus too much on the specifics of IP version 6 addressing. Just know that the /64 range fits inside of the /48 range to be a valid subnet range inside of that address. Next, you need to be very familiar with what I would consider to be a networking 101 topic of the private IP ranges that correlate with the RFC 1918 standard. These come down to your classic Class A, B, and C address ranges, in which you have your 10/8 prefix for Class A. Your Class B ranges are the 172.16 with a /12 prefix, and your Class C ranges are your 192.168/16 prefixes. It is an expected exam requirement to recognize a private IP address that falls inside of those ranges versus your typical external IP ranges. Next, when it comes down to the fundamentals and planning out IP addresses for your network, you need to be familiar with a few restricted IPs or IP ranges that are specific to Azure. For any individual subnet range, there are effectively 5 IP addresses you are not allowed to assign to your virtual machines. For example, in a /24 subnet range, the .0 address is reserved for the network address, .1 is reserved for your default gateway, and .2 and .3 is reserved by Azure to map the Azure DNS IP to the virtual network space. And also be aware that the very last possible IP in that range, in this case .255, is reserved for the network broadcast address. These are the first 4 addresses in a host range, as well as the last one for 5 total. This means if you are creating a subnet with a /24 address range giving you a theoretical max of 256 host addresses, the actual number of usable addresses would be 256 minus 5, giving you 251 actual addresses available for your host pool. And then finally, before moving on, there are a few specific IP ranges that are reserved by Azure you also do not have access to. This includes a multicast range, broadcast range, loopback, and link local. And there's also an interesting range at the very bottom called internal DNS, which is going to be another ongoing topic in this course, especially in our discussion of working with DNS in the next session, which is 168.63.129.16. This address is often referred to as the Azure Wire Server address, which is a globally available IP address that Azure uses in the background to manage a large number of different network communications. We're going to talk more about this address in more detail when we talk about DNS in the next section. Moving on, there are a number of different IP types or configurations on Azure and working with networking in general that you need to be familiar with, both from a general and an exam perspective. The first type of IP configuration should be familiar to anyone who's worked with networking before, which is static versus dynamic. On Azure, a dynamic address, which you can kind of think of as a DHCP address, for public IP addresses will change every time your virtual machine is deallocated and reallocated. In other words, if we have a virtual machine with a dynamic public IP assigned to it, when you deallocate and then reallocate, or in other words, turn that VM off and back on again, it will then be assigned a different public IP address. By comparison, a static public IP address will remain in place every time that virtual machine is then deallocated and reallocated. Keep in mind, though, that when working with public versus private dynamic IPs, it is a little bit different, in which a private dynamic IP will remain associated with that network interface card, even if it is deallocated and reallocated until that network interface is later deleted. The other configuration type, again, should be familiar to most of you, is public versus private. Public IPs are, of course, public to the entire internet, and a private IP falls inside of that Class A, B, or C range, which is only available to private network resources. Although keep in mind, one interesting behind-the-scenes fact is that a public IP address on Azure is actually associated with a private IP or attached to that private IP as a separate public IP association. The last type of IP configuration to be familiar with, which we are going to expand here in just a second, is there's actually 2 different SKUs available on Azure for IP addresses, which are basic and standard. Now, there's a bit of nuance with that we need to go ahead and break down. Let's go ahead and do that now. So when working with IP SKUs, once again, our 2 different types are basic versus standard, and there is going to be an expectation that you are familiar with the differences. Starting off with the basic SKU, know that basic SKU IPs can be either static or dynamic. They are open by default, which from a security perspective means that when you have a basic IP assigned to a virtual machine, all incoming traffic to that VM is allowed by default. If you want to filter out that traffic, a network security group must be created to block incoming traffic. Otherwise, all incoming traffic will be permitted to come through. Also, with basic IPs, there is no availability zone redundancy, and you also have less granular routing options with basic IP SKUs. By comparison, working with standard IP SKUs are static only. You cannot have a dynamic standard IP SKU, and that's specifically referring to IP version 4. Compared with the basic SKU, all standard IP SKUs are secure by default, which means that for standard IPs assigned to a virtual machine, all incoming traffic is blocked until you create a network security group to explicitly allow certain types of inbound access. And also compared to a basic SKU, you do have zone redundancy, and it gives you more granular routing options compared to the basic SKU. Now, let's take a look at a specific exam focus, which is going to be an ongoing topic throughout this course that you need to be familiar with when it comes to different managed services on Azure. There is going to be an exam requirement that you understand different types of IP configurations that are possible or required for different managed services. And we have a little bit of a preview on the right side. For example, for different managed services such as load balancers, virtual network gateways, NAT gateway, etc., you need to know which managed services require only static addresses or static and dynamic, which SKUs are possible for different services such as a basic SKU, standard SKU only, or maybe both. For example, on the right side, we can see that NAT gateway does not allow dynamic IP addresses and static only, and we will also talk more about those services later on when it comes to the SKU that is required for those services as well. Now, once again, this is going to be one of those ongoing discussions. When we talk about individual services, we will also address the specific types of IP configurations that are required for each one. So this is going to be an ongoing detail that we are going to continually refer to. With that in mind, there is also an at-a-glance link that Microsoft provides in their documentation, which we can see on the right side when it comes down to the breakdown of services and dynamic versus static and other configurations as well. And we will attach that at-a-glance link to the resources for this lesson for your own reference. With that, that's going to conclude our overview of the fundamentals of IP addressing on Azure. Once again, quite a bit of ground that we covered. Let's quickly cover our key takeaways from this lesson before we move on. We started off by learning that IP addresses are actually associated with a network interface resource on Azure, as opposed to being directly attached to the virtual machine itself, from which we learned that a network interface can host multiple IPs and virtual machines can have multiple network interfaces attached to them. We also revisited our relationship between address spaces and subnet relationship. This is another one of those key topics we need to be familiar with, in which we learned that a subnet must be contained inside of the parent address space, and that requirement is true for both IP version 4 and IP version 6 addresses. And then finally, we learned about the 3 different types of configurations that are possible when it comes to IP addresses, which include static versus dynamic, private versus public, basic SKU versus standard SKU, and there will be an ongoing requirement to know which network services require different above combinations. That's going to go ahead and wrap it up for this fundamental lesson of IP addressing on Azure. Let's go ahead and move on to the next one.